Hello, everyone. Thank you for taking your time and joining us today. My name is Marta, and I'm going to be today's moderator of our event. Before we start, I would like to say that you may ask our speakers questions, of course, in the YouTube chat, and we will read and answer them after each speech. So, last but not least, there is a feedback form below the stream. So, we will really appreciate if you could fill it in after our event. And today we have three speakers performing, and we will start with Kirill Semenov, DevOps Cloud Team Leader at DataArt, who will talk about the business value of DevOps. So, not to prolong, Kirill, the stage is yours.
Thank you. Hi, everyone. So as mentioned, today we're going to talk about business value of DevOps. And before we continue, I wanted to tell a couple of words. Why is it so important to talk about it? I think that it is very important because we all work with business and business success is our success. And in order to have successful cooperation with our clients, we need to understand what is the business value, what business value the DevOps brings. Couple words about myself. I work more than 8 years in IT. 4 of them I work as a DevOps, and last 2 years I also act as a team leader. So today we are going to cover the following topics: the business value of DevOps, a couple words about DataArt expertise, trends and high-level tech landscape, and typical DevOps engagement profiles. So the value of DevOps. Basically, it consists of 5 major things. The first one is agility, which means generally more often releases and ability to implement changes faster. Then it's quality through automation, and there's a principle that everything that can be automated must be automated. Then it's obviously saving time and money. Then continuity of business through mobility or ease of changes and through automation. And governance. Governance is the control of costs and resources, which is very important for our clients. Couple words about metrics, how we can measure the success of the process. The first one, called lead time, it is also called the time to market, and basically it's time between start of work on some new feature and time when this feature gets to production. Then we have rate of failures of deployments and changes brought to the project. Then we have time that it takes to prepare for release and perform the release itself. The frequency of release is a very important metrics, how often we can release. The downtime of the product, the repeatability of actions in the project, mean time to recover and mean time to detect. It's the time that it takes to find a problem and fix it. And team velocity, which stands for how fast the team can develop the product. Let's elaborate a bit about the success of the companies that follow the DevOps best practices and approaches. So according to State of DevOps by Puppet, the most successful companies are characterized by the following. First is the multiple daily on-demand deployments. So we deploy not when we can, but when we want. Then it's the time that it takes to commit the new feature to production and fix if something goes wrong. If it's less than an hour, that's a perfect characteristic. The very low rate of the change failures, which means that changes brought to the project are not bringing failures, and the high degree of automation. So we see that 65% of testing is covered with automation, and more than 70% of configuration management and deployment is automated. And of course, the systems that are well implemented and backed up, they are covered from unpredicted failures, and teams can spend their time on creating something new, not fixing something old. Couple words about DataArt expertise. DataArt has pretty wide expertise in both DevOps practices and approaches and in cloud. So with the CI/CD, the infrastructure as a code, the logs, analytics, and so on and so forth, and with major clouds as well. A couple words about the DevOps maturity model, how we see it in our company. There are four initial maturity models for a project. The first one is manual, when there is no automation. Everything is slow, not secured, and fragile, and the process involves a lot of people, and including developers. The next one, the initial stage, when the automation is on initial phase, but deploy is still fragile and needs special knowledge. The next one is mature, when pretty much things are automated, but there are still issues with logging and transparency of the process, and initiating the process is not that obvious. And we have eventually the advanced phase, when all things that can be automated are automated, and the process seems perfect, but it also has disadvantage because it is very expensive to build up such a process, and it needs the involvement of very skilled engineers. The modern DevOps pipelines, how we see the SDLC process. So the build automation and continuous integration and test automation that we all know as a CI, the deployment automation, well known as a CD, the automatic configuration management and infrastructure provisioning, and of course, monitoring, alerting, and logging. A couple words about trends and about trends. So first one is infrastructure as a code, when we automate the infrastructure provisioning. Nowadays, it's a must-have for a successful project. The next one is containerization of the application, the CI/CD approaches, the build config as a code, an approach when we put the build configuration in source file in repository, and it is called from different environments with different parameters. It is really easy to manage having such approach, and it's very convenient to reuse. The next one is disposable ephemeral agents. The idea is on demand of building or deploying something, a new agent is being bring up it runs the job and then it goes down. It saves a lot of money. Next one is no downtime during releases and disaster. And the next one is the separation of the CI/CD. Why separation? Because there are a lot of tools that are dedicated to CI or CD, and they have more out-of-the-box services and tools that help perform CI and CD better. For instance, like Octopus for CD, it has really great management of artifacts. Then we have OpenTrace. It's the microservices logging. Then we have the Open Policy Agent. This is a new thing. It's kind of policy as a code, like the infrastructure as a code. The policy is being built up in the code. In DataArt, we performed an R&D with such approach. Then it's advanced operational analytics with machine learning. It's key to successful decision making. Then it's DevSecOps. DevSecOps is an approach when security aspects are being built and set up on the initial phase of the SDLC, not when all things are already set up and you need to go somewhere and set up security there, which is not a good practice. So DevSecOps is it's an approach to start working on security on the very initial phases. And the last but not least is AI Ops. It's about the analytics of operations with the artificial intelligence that helps visualize operations, the results, and perform some actions. Couple words about technologies. You can see here number of technologies, all are well known. I would drag your attention to cloud native tools. Right now we have cloud SaaS for a CI/CD, which is really convenient. It takes you just a couple of clicks to set up the CI/CD flow from scratch using cloud tools like AWS CodeStar or Google Cloud Build or Azure DevOps. Really convenient. Couple words about DataArt expertise with clouds. We have partnerships with the main clouds AWS, Azure, and GCP. Rich experience working with others, and we also have experience working with private clouds. And let's talk a bit about the typical engagement profiles. Generally, I group the engagement profiles into four categories. The first one is money. When client lacks control over their spends, for example, the infrastructure expenditure control, or clients thinks that the cost of infrastructure is too much, that he spends too much money for the infrastructure. The next one is time. When a client has problems with getting results in time. For example, the time to market is really slow, or the regression cycles took too much time. The next is stability and quality. For example, the fragile deploys or any changes to the infrastructure bring some breaks, some unpredictable results, or the infrastructure reliability is a concern for clients, so he is not assured that his product his product is safe there. And the last but not least, the trends. When a client comes with number of buzzwords and he wants to have all those buzzwords implemented in his project to have his product working the best of the best on the market, like migrating to cloud from on-premises, or using Kubernetes or any other things that he wants. And when we talk about the DevOps in a project, we need to remember that in general, the DevOps as an approach, it's not just a number of tools. It's an approach. First of all, we need to remember that this approach is an essential for the project, and it brings really big value to everyone, both to client and to us as vendors. So I think that's all from my side. Thank you.
Thank you very much, Kirill. So do we have any questions from the audience? I don't see them yet. Maybe let's wait a minute. But if not, I'm pretty sure that you can find Kirill on LinkedIn and you can drop a line whenever you want, right, Kirill?
Of course.
Okay. All right, I don't see any questions so far. Maybe if something appears, we will get back to you if it's all right. So not to stop our next speaker. So thank you everyone, and thank you Kirill once again. And now we are having another speaker waiting. So I hope you are staying with us, because now it is time for Alexander Snegovoy, DevOps and Cloud Architect at DataArt, who is going to talk about challenges of continuous development strategy. So Alex, now the floor is yours.
Thank you, Marta. I'm sharing the screen. Okay, so you should see it now. Yep. And today, hi everyone, first of all, and today we're going to talk about the challenges of continuous deployment model that could appear in your project. First of all, a few words about myself. I'm a cloud and DevOps architect at DataArt, and most of the time I'm helping clients to migrate to public clouds or to use them properly, optimize costs, and do cloud native development. Also, I'm certified architect in AWS and GCP. Our agenda is going to be the next. So we'll talk about what is a continuous deployment, whom does it fit, and whom it does not fit. Also, and then we'll talk about the challenges you might face. And then we'll leave some room for the questions. So first of all, what is a continuous deployment? You should be all familiar with this model, with this diagram. Basically, at the top, we have a continuous delivery, meaning we have almost all these steps automated except the actual deployment. So practically, you have to go and click to the button to deploy something to production or to any other environment. This is a well-known approach, but what if we can automate everything? What if we can deploy directly to production through all the, if our application passes all the quality gates? That's what is a continuous deployment about. And the general idea there is that you have all the steps automated and you always go to production with each commit. So it leads us to some of the concerns, and first of all is first concern is that it's quite expensive, meaning you have to automate a lot of different stuff, and it's not always the best solution, but in the long term it pays off. Also, what is really important here is that it must be the only way you deliver changes to your environment. So there shouldn't be a case in continuous deployment where you log in via RDP to the server and restart the web server, for example, or deploy some configs there. It shouldn't be the case in continuous deployment. So the easiest way to deliver changes there is with containers. That's obvious. So it's also a must. And I think that should be considered. Continuous deployment is not it's not one thing that fits all. Meaning, if your project requires, let's say, signing each release by CTO of your company, or some strict regulations or some compliance reviews and stuff like that, then continuous deployment is not possible because there is still a manual process to approve or to deliver the changes. So we can now talk about the challenges that people brings because of the bureaucracy, and that many people just are thinking that, okay, we don't have to release multiple times per day. We can release twice a month or once a month. And why should we bother? The idea there is that continuous deployment is not something that can be fit to all the project, but you will spend less time clicking buttons with this, and you'll reduce the chance of human error when, for example, you deploy something to production that should not be deployed. Also, with this all concerns, many people are just simply resistant to changes, and they do not think that pipeline is well created, and the team is big. We have 70 or 80 people, so how can we track this? We have multiple microservices, tens of them. How can we synchronize all these deployments? And most of the challenges, they could be easily resolved when everyone follows the process, and when not only the ops part of the team is responsible for the production, but the whole team is responsible for the product. So it means that the team must be T-shaped in this case. So there won't be a case when you wait for a person who is responsible for Jenkins or stuff like that. So the team the key here is that the team must be responsible for the product. Then, okay, we have some challenges from people, but what about the process, right? Either it's Scrum or it Kanban, or the SDLC in general. The problem with the continuous deployment is that it requires a lot of tests. There is we cannot have enough tests. Basically, that's the idea of continuous deployment. If you can test something, this should be tested and this should be automated, because it will help you to be more sure that your application is actually working, and you do not spend some time testing on some of the environments manually. Also, we again should think that not the not some ops or DevOps teams responsible for the production, but the whole team. Then we have we do not have a QA team, we do not have dev team, we do not have ops team. We have just the team, and this team is what is responsible for the product. And the ideal case for the continuous deployment is that you have just a single environment, right? So you have the fastest release possible. You just release to production and that's it. But it's not always the case, and we could have multiple layers of different environments with multiple devs, multiple stages, UAT environment, and something like this. And that's still okay in continuous deployment. You'll have just a little bit longer cycle, but again, it can be fully automated. For example, during the build, you're running unit tests. On the development environment, you're running some integration tests. On staging environment, you're running performance tests and stuff like that. And the important thing here is that you should have all your tested automated, right? And it means that you must not have the document where you describe, like, I have to go click there, then I have to go to another system, get some data from there, pass it somewhere else, and stuff like that. So in general, you should not have non-executable testing models, so you can have everything automated. Another problem that appears here with all this automation, with all this tooling, is tooling zoo. So we have a lot of different products, and if we are using some cloud offerings, it's okay. We do not have to manage this, but we do not have to manage this from the ops perspective, like upgrading servers and stuff like that. But we have to manage users, we have to manage access, we have to somehow, with the code, control pipelines, control tests, and all this stuff. So there is still a management cost to this. And the less tools we have, the better, because the less management cost for this. But the important thing here that you should keep in mind is that the monitoring should be comfortable. It must be comfortable, because if you cannot define where there is quickly, because you deploy directly to production and you do not have to click to the button to deploy to production, you must be able to see where the issue is really fast. And the more comfortable monitoring you can get, the better. If it's a unified tooling such as Datadog, then it's good. But if you have some different tools like Prometheus, and then for monitoring, and then for logging aggregation you have ELK stack or something like this, then it's still okay. But it should be comfortable for you to get where there is fast. That's the key. So errors might appear in a lot of different places, and it's okay if it appears in the code, because it could be fixed really fast by the development. But what if the issue appears in infrastructure? You do not specify the correct routing tables, and traffic simply cannot go to the right place. Then you should be able to define it there, and that's why the comfortable monitoring is a must. With infrastructure, we see another challenge. We see some other challenges, and first of all is the cost of the development, because we have a lot of the things automated, right? We have infrastructure as code, we have configuration management, we have some configuration management for Kubernetes, we have configuration management for databases, for Linux, for many other tools, and we end up in in a hell of infrastructure and configuration as a code. So we should be. This is something unavoidable if you want to have a CD, a proper CD, but you should be able to navigate there quickly. You should have a strong automation around this, so you do not have something that you run manually, like some script to bootstrap, for example, to bootstrap an initial configuration. No, it should be a part of the creation of the configuration. And here we see that we have infrastructure like creation of the resources, installation of the database and stuff like that. And we also have a configuration that also should be automated. And that means that we should not keep all these two things together, because you end up in a position where you have everything, let's say, in a single repository, and the blast radius of your changes to a configuration is really huge. It can affect infrastructure if you do something improperly. That's why in this situation, I believe you should split infrastructure and configuration. Also, the very important thing is backups. You cannot have enough backups, but what you should also have is ability to revert to this backup automatically, because it's a continuous deployment, and you should be able to test them, because we all know what happens when we are taking a snapshot of a persistent disk in the cloud, but how actually it affects our application when we are trying to restore from this backup. What exactly happened into our application, how much downtime we have, what are other things we see, like some, for example, bad requests, and we're not able to write data to the database. So these things, they have to be tested, and the automation should be built around this in order to be agile and to do things fast. Then the monitoring, again, I'm emphasizing that monitoring is the must, and the comfortable monitoring is must, but monitoring must be meaningful. You can have, you can basically monitor many things, but if you do not see any useful information there, then what is the point of the monitoring, right? So you should define something called SLIs, service level indicators, properly, and you should be able to monitor them properly. So you could define what is happening. Like you can define with this whether your application is working or not, and this is going to be a clear definition, which is easy to track and which is easy to scale when your application grows. But what, for example, I can define a slice on my internal services, but what if I have external integrations, and how can I monitor these? These are also the challenges that you should keep in mind, and try to somehow mitigate, for example, and try to monitor this properly and set up the right tooling, which can help you to define if it's an external system that is that changed the contract of their APIs, or it's something on your side that is that's not been deployed correctly. So we also see that the backward compatibility of the changes we are producing and is something important there, and not only for the code, but also for the database, because we can quite easily revert the code. we just redeploying the previous binaries, or we just redeploying the previous commit, and that's it. But what about the database? There are multiple approaches to this. For example, we can stick to the approach that we are not doing any reverts to the database, and it means that that the team should react fast, and even under stress should be able to fix application and the database with the shortest time frame possible. Another approach that we could take with the database changes is to write revert scripts. Yeah, when we're writing a migration for the database, in many frameworks we have a place where we write the function that is going to perform the changes to the database, and we have a way to write the function that is going to revert these changes. So it means that you are doing changes to the schema, not to the data. That's what is important there. And the CD is really suitable not only for microservices, but it can be suitable for monolith if you're doing zero downtime deployments. And of course, it's going to be not as fast as with microservices because they're small and monolith is big. But again, it's something that should be that you can think about. And if you're having a monolith, it doesn't mean that you cannot have a continuous deployment. Yeah. A good thing that, okay, we have, for example, people ready to the continuous deployment. We have our process established. We have our architecture suitable for continuous deployment, and we keep track of everything. We monitor everything. We back up everything, and we have a strong automation around everything. But what about the tests? Tests should be, in this case, there should be a lot of them, right? They must be defined on all the levels, like unit tests, integration tests, performance tests, API tests, and all the other UI tests and stuff like that. Also, the regression tests in continuous deployment world, there shouldn't be a case of manual regression. But what is more important, that the tests, they cannot be flaky in this case. So you cannot, if you run a test and it passes, then within the next run it should pass as well. If your test doesn't pass, then in the next run it should not pass as well. That's the very important thing. That if of course you're running the tests like the same tests test suite. Also, the important thing here is high availability and disaster recovery for infrastructure and for application, and this also should be tested. Of course, you cannot have disaster recovery plan written and just test it just to pass regulations and test this thing manually, because with continuous deployment you're doing changes frequently, you're doing them constantly to your production, and it means that you should test your application for high availability and for disaster recovery always. There is a process established for this called chaos engineering, defined by Netflix. The idea there is that you are running, instead of assuming that something could break, you just break things and see what is going on and how your application behaves. That's the idea behind chaos engineering. There are a lot of different tools to perform this. So there are a lot of different ways to automate this, because chaos engineering tools are now quite advanced, so they could break something and revert to the working state. For example, they could kill all the traffic in the VM, and then they can simply restore it, and or they could shut down your VMs and then start them, stuff like that. So this is something that you should also do in CD world to be successful and do these things properly. So to conclude how we can live with all of this, the first thing is that we should automate everything. Business value of this thing is something that's proven. If you performing something once or twice, it then can be performed many times after, and it has to be automated to avoid human errors and to speed up the process overall. This also requires people to follow the process, and it only pays off when everyone follows the process. So the team is responsible for the product that is running in production, and all the team should be defining like the monitoring. All the team should be defining SLIs, and all the team should be able to find the issues fast, because they are going to be issues, and that's something unavoidable. And it only pays off when the team is responsible for the product. And in case that the issue is something that requires backups, of course you must have them. And in order to define how your system behaves, you have to simulate failures with the chaos engineering practices. You have to test your backups to see how they are working. And to achieve all of this, the team has to deliver the smallest chunks possible, meaning you're not delivering the whole feature, which is like touching 20 microservices. You are delivering some small features, some backward compatible chunks that can be easily reverted and that can be easily consumed by all of the tooling you're building around this CD process. So that's it. That's it for today from my side. Thank you everyone for joining, and feel free to reach me on Facebook or LinkedIn. Also subscribe. I regularly post useful information about DevOps, clouds, and tools overall. And thanks everyone again, and feel free to ask any questions.
Thank you. Thank you very much, Alex. So actually, we have one question from our audience. So the question is, in your practice, how many % of CI pipelines also include CD stage?
CI pipeline is okay. I think if I got the question right, we usually try to split CI and CD part. The reason why is because the idea of CI is to produce an artifact, and the idea of CD is to deploy this artifact somewhere. So if you have all of this in a single pipeline, if we can talk about this in terms of jobs in Jenkins, so if you have this in a single job, then you're stuck in a position where you're trying to redeploy something, you are rebuilding the same thing that has already been built. So the idea there is to split this. So after CI, you can trigger CD, and you can always trigger CD. So you can always trigger CD by itself, and it will consume an artifact produced by CI and deploy it somewhere. So if we're talking about the practice and the and what we regularly see, at least from my experience, we always have we're trying to have some sort of separation, but there is still a small percentage of the clients and companies that just have a single big pipeline to do, that is doing all the tests and all the deployments and stuff like that. I believe if I've got the question right, that's the answer.
I don't see any comments, so I guess your answer is clear. If not, you all have contacts to Alex, so you can also catch him. So thank you once again. And now, last but not least, we are having one more speaker, Borislav Traykov, who is a DevOps team leader in Verint Cyber Intelligence. So we are very grateful that he accepted our invitation. So Borislav is going to show us how to start with Jenkins. So Borislav, it's time for you. Are we ready?
Yes, Marta, thank you very much. Do you hear me well?
Yes, everything is clear. Stage is
Great,
yours.
great. Thank you very much. Thanks for everyone who joined us at this time. Currently in Bulgaria, it's almost 7:30 in the evening. For some people, it's 4:30 in the afternoon. So this is a really fun global event. Okay, let me check this. Okay, my topic in today's webinar is CI from scratch with Jenkins. As Marta announced me, I'm Borislav Traykov, also known as Bobby. I work in Verint, the Bulgarian office called Verint Systems Bulgaria, and I will be taking your questions at the end of the presentation. Oh no, but there is one question here. Why is this guy going to talk to us about Jenkins? Well, prior to starting to work with Jenkins almost as a full-time job, I actually had experience with doing continuous build, test, and deploy using Microsoft TFS and Octopus Deploy from the period between 2013 and 2015. And then when I joined Verint in 2016, I became the captain of a Jenkins system that is currently serving the needs of 15 dev teams. And I started from scratch. There was a small Jenkins instance when I started, but it was running on a Windows Server 2008 instance on a VM that nobody wanted. So the developers got it so that they could build their own continuous build processes. They had only nightly builds. It took 2 hours for the VM to restart in case there were any issues or any reason to restart it. So I looked at that VM, I said, that's not good. And I started from scratch. And I've been building on top of that scratch ever since. Currently, my team is supporting 500 plus jobs for continuous building, testing, and deployment. Sorry, to Levon's question to Alexander, nope, we don't have continuous delivery. We are one of those other companies. And finally, I want to talk to you how to start from scratch, start your CI processes from scratch with Jenkins, because I have the drive to provide clarity and reusability to everything I do. So even if you start anyhow, that's something that I want to emphasize throughout the entire presentation. Clarity and reusability. With continuous integration, you're probably going to have reusable components. So might as well make them reusable as soon as possible and provide clarity. Both Kirill and Alexander emphasized on this, but I also want to emphasize again on quality. Now, how to start with Jenkins is a good question. And the answer is actually very simple. Jenkins is a Java application. I know, huge surprise, but it is. It's using a regular Java application server. I think the most common one is Tomcat. It's using Jetty as a web server, and that's it. It's a Java application. It's not something uber complicated like a Kubernetes cluster, for example. And as such, you can install it, run it, and start using it. Minimal initial configuration required. You can have Jenkins up and running within 5 minutes with a basic setup, of course. And here's the other part, and initial expectations for added value. Usually when you start a CI process in a company which has no idea what CI is, you have to sell what's the value of CI. This is what Kirill and Alexander mentioned multiple times in their presentations. With Jenkins, in my experience, the initial expectations for added value are reduced time for the automatable processes, having as many automatable processes actually automated, and doing that consistently, providing perceived performance to everyone who is consuming Jenkins. In my use case, people who are using Jenkins, my team's customers, are the other dev teams, but also our operation teams, but also the managers of all those teams. So those are the people who have initial expectations to CI processes that Jenkins will be running. Before I get to the technical part, I want to talk about how to start with Jenkins in your head. The first point I want to make here is that I recommend you reserve time and energy for communication. Jenkins is not like a small feature in a big product. Jenkins is a standalone system which is meant to be in between other systems. And not only that, but it actually has human interactions. For example, Jenkins will shoot an email to people relevant to a given build job. Jenkins will notify the person who triggered a deployment. So, and as I said, maybe managers are looking at Jenkins. So unless you delegate time and energy for you to communicate with those people that, hey, for example, this is the build job, this is how much time is taking, or we don't have build jobs for everything, but we are starting with this. And as Alexander mentioned, we're going to separate each component in its own build job. So we have a roadmap. These things need to be communicated because your customers may think that Jenkins is going to automate the product, and they may see that as a one whole thing, something indivisible. It will be your job to tell them this is actually divided into tiny pieces that will go into Jenkins one by one. This also ties into my second point, clarity of execution. If the execution of a Jenkins job is not clear, people will say Jenkins is not working. This is actually something pretty common in my daily experience, even 4 years after I've established Jenkins as our go-to continuous integration center. People can still say Jenkins is not working. And they will mean stuff like my build job failed, the deployment failed. So it's you may end up in situations like these, and you have to provide the clarity to communicate that, hey, it's not that Jenkins is not working. It's just that, for example, you have a compilation error, or maybe an external dependency failed to be downloaded. Things happen, but it's very rarely that Jenkins itself is not working. If you provide clarity, you can point to the specific reason. You can do root cause analysis of any problematic situations. Next thing, expose opportunity for repeatability. They say that the definition of insanity is doing the same thing over and over again and expecting different results. Well, that's true. Since these are continuous processes, they get repeated. So you want to ensure that if you repeat the same process, the same job execution over and over again, you'll get consistent results. For example, if you are building a Node.js application, you want to make sure that even small code changes will go through the exact same process in the exact same circumstances. This may sound very clear, very obvious, but actually, I have seen other Jenkins instances which rely on stuff that is makes repeatability hard. For example, they rely on a specific set of files being on a hard-coded path, which is related to the current job's execution. So it's something that maybe somebody needs to reset between each job execution. These things don't allow for repeatability. So this is, again, something that you can plan when you start by just running Jenkins as a simple Java application. Identifying and communicating issues. This ties into clarity of execution. If you provide clear information in Jenkins, in any way, be it log files, pictures, reports, you can point people and you yourself can identify issues. For example, as I said earlier, I can point people to compilation issues. I can point people to problem with external resources. And also, I can find out problems specific to Jenkins, which may actually happen in some special circumstances that are hard, that cannot be repeated on a developer's computer. Taking into account external factors. Jenkins very rarely lives in isolation. It relies on external tooling to operate. It relies on external artifact repositories, networks for communication with, let's say, destination VMs for deployments, with your source control system for building stuff. So Jenkins may end up in the same Jenkins is not working situation, maybe because the network connectivity to the source control server is down, maybe because the source control server is down. That doesn't mean that Jenkins is not working. But people may view it that way because for people, people tend to take the path of least resistance. If you give them Jenkins, they will look only in Jenkins. They will not take into account such factors. It may be your job to take them into account and address any problem with such external factors. Finally, code is code, even if it's a script, even if it's a simple shell script. From here, and I know that this is psychological advice, if you write script, try to put it in some form of source control. The fact that you can come up with a simple shell script doesn't make it simple to your colleague or to the person who will take over after you. Simple is in the eyes of the beholder. And also, what if it gets lost? What if somebody changes it? Code is code, even if it's a script. Now, how to start with Jenkins on the technical side? 5 terms I would like to point your attentions to. The first is jobs, also more commonly known because of other continuous integration products as pipelines. This is the first thing you will do in in Jenkins. You will create jobs which will do what? Well, the very first step for a lot of people is to write down a shell script on their computer, copy it, and paste it into the body of a new Jenkins job. So essentially, when you start with jobs, you may consider them as simple wrappers for what you would execute on your machine. That is fine. That may be fine for many years, but honestly, that's not the only approach. There are other approaches, as I'll get to in a minute. Command line interfaces or tools. As I said, when you are starting with jobs, you are writing some form of shell script, even if it's a call to, let's say, your build technology. For example, if you're building a Node.js app, you're calling npm or webpack. Hey, guess what? Those are command line tools. So again, they are not parts of Jenkins. They are just things that your Jenkins jobs will leverage. So command line interfaces have versions which may get updated or outdated. Command line interfaces have to be installed on the Jenkins machine or machines or provisioned in any other way. But they're there and they're outside of Jenkins. Third term is the plugins. Plugins, Jenkins, like I said, is a Java application. It's basically a big task scheduler, similar to cron tab on Linux. But with plugins, you get extended functionality in your jobs and outside of them, even for the entire Jenkins as a system. With plugins, you can say, hey, writing my build or deployment process as a shell script is not something pretty to look at, or maybe it's not optimal to keep it as a simple shell script. With plugins, Jenkins will enable you to write more complicated stuff with less, either giving you a UI if you're using freestyle jobs, or it will give you specific operations if you're using the pipeline approach. So plugins, there are a lot of them. I actually have a lot of content related to plugins throughout the rest of the presentation. So they are very, 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 very useful. And 99% of them are open source. So if you find a plugin that you want to use, most likely you will be free to use it. Jenkins management. This ties into managing Jenkins as a running system, just like a system administrator would manage a mail server. Jenkins, in your case, may never change for 10 years. But in my case, I want to keep it up to date. I want to make sure that it meets the ever-changing demands of my developers. So Jenkins management is also something that you may need to do. For example, installing new plugins, installing updates, but also defining external tools, defining credentials, defining reusable files, and finally, control flow. Control flow, I mean it in the sense of using it in a program language, which means the flow of control. So if we go back to the example of a simple shell script, nothing too complicated, either a line which is 10,000 characters long or a shell script which is 500 lines long. Well, maybe that can be split into smaller jobs that will rely on each other. That's the flow of control that I mean here. You may split sections of your logic into their own jobs. Tips and good practices. Really, there is no good go-to source for information about Jenkins. It's not like Java or C#. There is official documentation, but it's being updated. There are so many outdated articles in the official documentation. There is stuff that's implemented as functionality, but it's not documented yet. So you also have blog posts and other articles, for example, by the creators of the plugins. So this is my first recommendation: read documentation, blog posts, and articles. The second is an icon that if you are using freestyle jobs in Jenkins, or actually having to configure anything in Jenkins, you have this button. If you click it, you'll get context-specific information about what you are currently trying to do from the creator of a given plugin or functionality. This is the information hidden behind these buttons is usually very useful. I cannot emphasize how useful it has been for me. It has saved me time for reading big documentation articles or long blog posts. I just get a few lines of text, exactly what I need, done. Read and write log messages. Preserve those log messages. If your Jenkins jobs do stuff, hey, maybe signify that something is done correctly. This may sound counterintuitive to the Linux's rule of silence, but I encourage you to write log messages. Even if something happens successfully, have a log message of when it starts and when it ends. Maybe you will have the need to know, hey, what time did it take for this operation to start and to end? Ensure enough repetitions are successful to prove readiness. Continuous processes are exactly that. They're continuous. They repeat, and they repeat without human interaction. So even if you create a job, for example, for building your Node.js application, even if it runs successfully on the first try, maybe it will fail on the second try. Maybe you'll get collisions of files, or maybe some files you are expecting to be deleted, but they aren't. That will be proven on each other repetition of the job after the first one. Same goes with even more strength for tests. Automated testing. You have to find out after a few repetitions that your tests are stable. Finally, reserve time and energy for unforeseen circumstances. This is a technical advice. Direct example. Last week, all of our Maven build jobs were working. At the end of last week, 5 of them stopped working without any explicit change from my team or from the developers. And as it turned out, we were using a Maven plugin without setting its version to a specific one. And the author of that plugin made changes after 2 years of silence. And one of those changes that he considered a bug fix actually broke functionality that we were relying on. So that was something that nobody expected. Or for example, your Jenkins instance internet may go down. What do you do then? Maybe you're not able to push or pull Docker images. What do you do then? Reserve time and energy. These things will happen. And in my experience, they happen all the time. Pipelines and the Blue Ocean plugin. So pipeline is a new approach, actually 4 years old already, of creating Jenkins jobs. Instead of using the UI of Jenkins to guide you with UI blocks of your steps, pipeline is configuration as code of your Jenkins jobs. It uses the Groovy scripting language from the JVM. It's nice. I think this is the direction where Jenkins is going in the future. But even 4 years after it's been introduced, I cannot recommend it as a first step. I can recommend it if you're willing to take the responsibility for it. pipeline jobs are, they may seem better for developers because it will be code. It won't be just UI blocks, but it's another programming language and it has its own specifics. So if it's in the UI, people may make more sense of, hey, what is this job trying to accomplish? Whereas if you use pipelines, especially in the beginning, where everyone is new to Jenkins and its processes, and you tell them you are now the owner of this Jenkins file, which builds your Node.js application. And if you want to make changes to it, you have to learn Groovy. Well, it's not for everyone. And BlueOcean is a UI plugin for Jenkins, which actually may restyle your entire Jenkins instance for pipeline jobs to look much, much better. So if you go with the pipeline approach at any time, I recommend also installing the BlueOcean plugin on your Jenkins instance as well. Docker. Docker is an interesting technological choice. We actually started using Docker in our company earlier this year. Imagine that. And I've been thinking about Docker in our CI context. Here are my 3 observations. You can use the official Jenkins Docker image to quickly spin up a brand new Jenkins instance and do some nuclear experiments on it. You don't need to do this on your workstation. You don't need a separate VM that you have to configure and reconfigure every time, because Jenkins configuration files are multiple. It's not a single config file. Also, you may want to install a different set of plugins. You want to experiment. You want to blow things up, especially when you're starting from scratch. You don't know anything. So just run the Jenkins container, do your experiments. If you like the result, put them on your Jenkins instance. But there is no one who is currently advocating for using a Docker container for your Jenkins primary instance, for your master. If, for example, you have Jenkins in a Kubernetes cluster, sure, okay. But people are still recommending to run the Jenkins master instance on an actual VM for nodes or for slaves. This is something that actually Kirill mentioned in his presentation, ephemeral slaves. So instead of preparing each and every VM that you may use for Jenkins slaves, you may create Jenkins Docker images for those slaves and spin them only if you need to. This way you have elasticity of your CI needs. You want to build 5 Node.js applications at the same time? Sure, spin up 5 slaves. You want to build just one? Sure, spin up just one. Especially if you're in the cloud, either public or private one, this can help you manage the balance between time and resources needed. You don't need full-on allocation of resources all the time. And finally, if you go with Docker images for your slaves, that will help you move towards the maxim that servers are cattle, not pets. Because in my experience, even to this day, my VMs are very precious to me. I have Node.js, Maven, Java installed here in a specific way. I have these certificates installed here in a specific way. If I lose this VM, I have to recreate it from scratch. If I use Docker images for my slaves, I can define the contents of my slave. I can start and stop as many containers based on that image as I want. That allows me to have servers as cattle. Cost of running a Jenkins server or system. Perceived performance. Maybe things are going slowly in your eyes or in the eyes of a senior developer, but if the managers are happy with the speed of execution, perceived performance is good. Even if, let's say, a developer wrote a huge monolith job that does a lot of things and it could be done better. If perceived performance by him is okay, you are also okay. So in my eyes, that's really huge, especially when you're trying to prove that Jenkins and CI has meaning, adds value. This is a human factor, perceived performance. Availability of resources, memory, storage, and network. Again, Jenkins does not live in isolation. It's not a command line tool. So it needs to have sufficient resources to do its work. This also means for its third-party tools to do its work. For example, if you are packaging an application, a big one, you need enough CPU to archive the thing within a reasonable time limit. Makes sense. Authentication and authorization. By default, Jenkins has anonymous access only, which means that everyone can do everything. And guess what? In the real world, everyone tries to do anything. And that usually leads to bad practices or outright making Jenkins itself not work. Changes to existing functionality. It will happen. When you are starting from scratch, you will realize that there are better ways to do things that you've already done. And you may need to communicate that with the people who already rely on existing functionality. Updates to the equipment. Maybe you need to update Jenkins or a specific set of plugins, or let's say Node.js or the slave Docker images that may require downtime. So you have to take into account downtime. Maybe the update will go wrong. Has happened to me a lot of times. Then you have to have sufficient time to say, hey, I have time to fix this. It's not Friday evening. I can fix it and not go insane. Server configuration. As I said, Jenkins uses a lot of tools in a big setup, and also Jenkins has a lot of config files. So keeping an eye out on the config file, on the configuration of all of this is important in the long run. Plugins. I'll scroll past the next set of slides. Because as my colleagues from DataArt are so kind to do, they put a link to this presentation on my SlideShare account, where you can see the full list of the plugins that I'm going to scroll through at your own leisure. So I've divided them into categories based on my recommendations from the previous slides. For example, and these are lists prioritized by me, so only on my own experience. So for example, here we have control flow plugins for passing control from job to job, control flow plugins for passing control between job steps, plugins for additional job functionality, extension of job capabilities, management and administration plugins. And here's an example of why plugin management matters. Because some people, and that's okay, can say, hey, I installed this amount of plugins and that's fine, I don't care. But plugin updates happen not only because of tiny bug fixes. Plugin updates happen because of introduction to new functionality and also because of security fixes. So this is an example of security fixes being introduced and notifying you about it. So it's your job, if you care more about security, hey, this is important for me to pay attention to. Maybe I'll need to schedule a downtime on the Jenkins system to update the plugins to their latest versions. Jenkins updates. Well, you have one button press mechanism in Jenkins for updating the entire Jenkins server. I mean, not the plugins, just the server. And you have two flavors of Jenkins releases. LTS, which stands for long-term support. That's the one I would recommend, and that's what I'm using because it's the most stable one. But if you want to experiment and get the latest functionality, you can use latest nightly releases. This is a quick example of an unforeseen and unexpected situation. I just did a Jenkins update, and 2 hours later, I saw this page which said manage legacy API token usage. And I was like, what? I didn't use any legacy API tokens, but it actually said so. So I had no idea that such functionality existed in Jenkins. If you're starting from scratch, you care about creating jobs, writing simple shell scripts, using plugins, and you get this. So such things can pop up. Jenkins is a complicated system, but I still advise you, especially when you're starting, consider it as a simple job scheduler with plugins. And this is the icon of something in Jenkins failing horribly. This is the exception icon. You may see it a lot. Don't be scared of it. Now, I can start taking questions from the chat. These are the links to my social media profiles. And also, since I'm working in Verint, we're currently expanding our office in Bulgaria. I'm looking for awesome colleagues. So if you know awesome people in Bulgaria, especially in Sofia, please send them my way. Thank you very much for your time and patience. I hope I managed to cover saying thank you in all of the languages relevant to today's audience. And very quickly, I want to show you the other stuff which you can find if you open my presentation in SlideShare. This is slide number 23 out of 68. So all of this are my notes on plugins that I like, and I would like to let you know about them. So all of this is available in SlideShare. And now, do we have any questions from the chat? I have it open and none for now.
Thank you, Borislav. So that was a really cool presentation. I don't see any questions so far. So as Borislav said, in the chat, you have the link to his presentation. So you may always come back to it and reach Borislav personally. And yeah, I think we can finish here for today. And once again, big bravo to our speakers, and thank you very much for joining us. And if you want to follow our next events, please check all the links below the transmission, and also follow our Facebook pages. And do not forget to fill in the feedback form, which is below the stream. So thank you once again, and have a good evening.